There were recently some closer-up images of those satellites, and some of them look like little squished flying saucer shapes. Yeah. I don't know. Actually, I don't remember which one this is. What they stuck this picture in, so I couldn't tell you.
Is it perfectly in the ring system? Is it perfectly in the ring system?
Right. Yeah. Yeah. A lot of these small satellites of Saturn are embedded right smack dab in the middle of the rings, and in fact. It appears that the rings are formed by pieces breaking off of satellites that are near the rings, and so the rings may actually be this sort of dynamic evolution between satellites breaking up and then reassembling again and then breaking up again. Yeah.
So we're.
I think they're all very, very close to circular. If they weren't circular, they'd be smashing into the rings all the time. And the ring particles are all on slightly different orbits, which is why they smear out into this big disk. So, yeah.
So we're still wondering about the physics that causes these things to form.
Mm-hmm. Yes, we are. We are. But there's a lot of interesting physics going on. I mean,
they're beautiful.
One thing you notice is that these waves are going in both directions. Actually, that's because the rings are orbiting faster on one side of the satellite and slower on the other side of the satellite. So the waves are propagating in opposite directions.
But we can't duplicate it in a lab, and we can't even dream about speculating for duplicating it in a lab.
What people are trying to do is model it on a computer.
Same
That's
thing.
the closest we can try to do.
Is this satellite in the ring itself, or is it just a computer?
Mm-hmm. They're sort of like embedded in these little gaps in the rings, and they leave
the dark portion of the ring, maybe.
Right, exactly. So a lot of those dark portions you see when you see pictures of Saturn's rings are little gaps that are left by these moonlets. And they set up these waves in the ring. This is one of the closest up images of the rings that Cassini got while it was going into orbit. And these are actually sort of waves going across the surface of the ring that are caused by the passage of one of those satellites. And you notice the rings are a little bit chunky when we get up close here. Some of these are like sort of railroad car-sized chunks of ice, all the way down to like little micron dust-sized chunks of ice that are all mixed together in these rings. So Saturn's unique in having this huge, massive ring system, and we see rings around other planets, but they tend to be very small compared to what we see around Saturn. And the problem with these rings is they're not stable over long periods of time. I mean, people who do these computer analyses, like you were asking about, say, well, maybe the rings will last about 100 million years or so, but that's short compared to the 4 billion year history of the solar system. So we're probably not looking at what Saturn originally looked like. So the rings used to be even bigger, and we're just looking at some remnant that's left over right now? Or were they somehow created recently? Was there a moon that broke up near Saturn and smeared out into this big ring system? These are some questions that we have about Saturn's rings, and what the Cassini mission is doing is getting a lot more data on how much mass is actually in these rings, what the rings are made of, so that we can test the hypotheses about where they might have originally came from. But most of what I'm going to talk about tonight is looking beyond the rings. Here we're looking beyond one of the rings toward one of the moons of Saturn. This is just a nice picture of the moon Mimas behind the F ring of Saturn. You can see these rings will have sort of transparent portions that are filled with sort of smoke-like particles, and then denser portions. Yeah.
The moon is not in the same plane?
The moon is in a slightly tilted plane relative to it. Yeah. It gets complicated.
If you made this stuff up, we would say you were crazy, right?
So, I personally am interested in all the satellites in the outer solar system. And this is just a montage of every satellite of all the big giant outer planets all in one place. And this row here is the collection of Saturn's major moons. Saturn has about 60 moons total, but there's only about 9 of them that really matter to me. Similarly, Jupiter also has about 60 moons, but I only care about 4 of them. So you notice, in contrast to, say, Jupiter's moons, where you have 4 big giant moons orbiting around Jupiter, around Saturn you have 1 big moon and a bunch of sort of little medium-sized moons, and then a whole bunch of tiny small potatoes beyond that. So Saturn's moon system is unique in having sort of one big bully dominating the system. That's Titan, and then all these little moons in between. So I'm sure that all of you know all the names of Saturn's moons.
Kurt Vonnegut taught us Titan.
So let's see. So this is Mimas, Enceladus, Tethys, Dione, Rhea, Titan, Hyperion, Iapetus, and Phoebe. That'll be tested over here. But yeah, don't tell me the others. Yeah. I can't do that. So I'm going to zoom in on just a few moons in particular tonight that I find interesting, where we found some interesting things during the Cassini mission. And the first one I'm going to zoom in on is this moon called Iapetus. And even in the earliest telescopic observations of Saturn, a few hundred years ago, it was noticed that this moon Iapetus was different from the rest. They noticed when it was on one side of Saturn, it was bright, and when it was on the other side of Saturn, it was much dimmer. And it sort of seemed to be going on and off like a cosmic lighthouse. Here's a Voyager picture of Iapetus that looks like a yin-yang. Half of it is as reflective as freshly fallen powdery snow, so bright white material. The other half is as dark as coal. It's really has a strong contrast between one side and the other. And this is one of the mysteries of Iapetus is, how the heck did this happen? Is the moon all dark and there's frost on one side? Is it all bright and it has dark dust on one side? Could it really be made of two different materials on two different sides of the moon?
Is the same side always facing Saturn?
Yes.
As with our moon? Okay.
Right. Yeah, all of these moons are locked to Saturn, meaning they always have the same face facing Saturn. And that's true of all the giant planet, all the major giant planet satellites. So, we were hoping that Cassini might be able to start giving us some insight into what's going on here, because that was just a fuzzy image from 1980 from the Voyager mission. And with Cassini, we've gotten much closer. So here's a closer picture of Iapetus. Here's the bright half here and the dark half over here. You notice this dark material is a little bit brownish in color. You may be able to only barely see it because it's so much darker than the light material. And it does appear, actually, that wherever you have steep slopes in the bright material, there's the dark stuff is cropping out. So it appears that this bright stuff is just some kind of like snow layer or frost layer that's covering part of the planet. Yeah?
Dark material, possibly carbon?
I don't think we have good data on that yet. It's so dark that you need to... the way that we usually gather that information is with a spectrometer, where you divide light up into a lot of different wavelengths and try to figure out what's going on. You need to stare at the dark part of Iapetus for a long time to get good data because it's so dark and reflects so little light. But we just did get some close flybys of Iapetus, but I haven't heard the results yet from what that dark material is actually made of.
What's the white material is?
What do I think it is? The white material is definitely water frost.
With water?
Yeah.
H2O?
Right. Yep. What do I think the dark material is? Yeah, good question. I believe it's probably like the dark material that we find on the Galilean satellites of Jupiter, which we know more about because we were there a while ago, and also in comets, where there's some little pieces of rock dust that seem to be mixed into cometary material. And there's also it's also possible that you could have organic carbon material that's sort of been denatured by radiation over time into a dark brown goo. Problem is that's hard to figure out with a spectrometer. You can sometimes see these organic dark goo stuff, but it doesn't have a lot of features that you can really pick out.